Welcome back to the next video in the DIDCOMM Superstack series. This one focuses on prototype 4. And it's really just a very simple change to prototype 3. I wanted to improve the multi-threaded asynchronousy of the prototype, particularly the way that HTTP requests were posted. I wanted messages just to be flying around. I wanted to be able to really, test out the asynchronousy, the use of the concurrent dictionary and concurrent queues, the adding and dequeuing of the encrypted messages, etc. So this is a pretty simple change. If we look at prototype 3, we had these loops where for every message we call send DIDCOMM message. What we did in the prototype 4 is just simply made it a simple change to send DIDCOMM message, and it does the HTTP post now as an asynchronous task. And to make the coding a little cleaner, we created an overloaded version of send DIDCOMM message that simply takes the endpoint and the core message. Remember, the core message has all of the routing information in it. It has the from key ID and the array of recipient key IDs. So we simply enumerate over the list of recipients and call the unoverloaded version of send DIDCOMM message. So that's really the only changes here. There's a couple, of course, programmatic changes up here where we just simplified the code for this entirely. We simply send the pull message to the URL. We've already encoded who the recipients are in the core message, and the same thing down here. So this is kind of editorial changes, if you will. So let's run this quickly. I guess the other thing I'll mention is that it was actually available in prototype 3, but we gather a bunch of statistics as we execute. And this is where I detected there wasn't very much asynchronousy. So we count the number of DIDCOMM messages, HTTP messages, the number of messages received in the handler, and then the number of VCs processed. So let's go ahead. We've got the one breakpoint down here. We can see at this point we have one VC processed. And if we look at the code, we'd have to scroll up a long ways, but we would see that at this point, all 6 DIDCOMM messages have been sent, all 6 HTTP messages have been sent. It's all been received. So where's stuff sitting? Well, it's sitting on the queue. So let's continue. We've got another breakpoint here. Let's continue one more time. If we go and look here, we can see that all the messages have been sent and received, and we have 2 VCs processed. Remember, in the end, we're just sending, or wanted to send, the KISS verifiable credential to 2 parties, and we had to do the exchange of the verifiable capability authorization. That's why we have 6 messages for 2 VCs, because there's 3 paths on the protocol. Thank you.